Hi all, myself Dr. Raji Thomas, Assistant Professor of Chemistry, Department of Freshman Engineering, St. Martin's Engineering College. Welcome to the section. Today I want to talk to you about determination of FluorideION concentration present in water by ion selective electrode method. Before going to the details of this experiment, I want to talk to you about the significance or applications of this experiment. So from this picture you can observe on small babies drinking water. Just imagine I am giving a glass of water to you. So first what you will observe? What is the color of that water? So it is a minimum requirement of drinking water. It should be colorless. Next what you can do? You can smell the water. So any foul smell is there or not. So after that what you can do? You can taste the water. So any taste difference is there or not. Okay. So smell, eyes, nose and tongue. You are using these sense organs to analyze the water, smell, taste and color. And these parameters are known as physical parameters of the drinking water. Okay. In addition to these physical parameters, there are some certain other parameters also, that is chemical parameters and biological parameters. Okay. So what is the meaning of chemical parameters? Chemical parameters means calcium, magnesium, fluorine. So these types of elements and compounds are known as chemical parameters. And what is biological parameters? Biological parameters means microorganisms like bacteria. Okay. But in order to analyze these chemical and biological parameters, we need some sophisticated techniques and sophisticated methods. With your sense organs, you can't analyze. Now, you know, most of the chemical parameters like calcium, magnesium, etc. is needed for our body. But why we needed? Calcium is using for bone strength. So like that, so many elements are required for our body. From where these elements or minerals are coming? From food and water. But if you are consuming water with a high concentration of these parameters for a long time runs, it will be a problem. So you have to drink or you have to consume these parameters within the permissible limit only. So just now I told the permissible limit. So what is or who is, next to my question is, who is deciding this permissible limit? There are certain organizations like WHO, ISO, ISI. So these organizations are deciding the rules and regulations of drinking water, and some other areas also there, means food, etc. So I am talking about only drinking water. So these organizations will give the rules and regulations for the drinking water. So this parameter should be this much, hardness should be this much, calcium should be this much. Okay. Now, you are purchasing some water bottles from outside. So you can observe in this picture, here one ISI symbol is there. Okay. So whenever you are purchasing one water bottle, outside you can observe one ISI. What is the meaning of ISI? Indian Institute of Standards. Okay. So this ISI is giving that approval. When they will give, I already told you ISI is an organization which will give some parameters for the drinking water or the limits. Okay. So whatever company you are purchasing, maybe Kinley or Bailey, so they will approve or they will keep the parameters within the permissible limit which is approved by ISI. That's why they are giving the permission so they can sell the water. Now you come to your own home. Okay, one example, you made one borewell. So in borewell water will be there. So maybe usually what you will think, your home, your borewell or your water. So usually it will be safe, like that you will think, but it is not the correct one. You already know nowadays pollution is increasing, so there is a chance of underground water pollution, and also in some other areas are there like Rajasthan. So Rajasthan, there is a large high amount of fluorine is in underground soil. So these factors can affect your water. So it's very high time to check or analyze your water. Okay. So today I am going to tell only one of the parameter from that is a fluorine content present in the water. So if you want to analyze your borewell water, what you will do? Normally you will take 1 liter or 2 liter of one water sample you will take from the borewell water. Then you will go to some chemical laboratories and you will give it there. Okay. So they will use some methods to find out what is the fluorine content present in that water. Then you can understand these are the parameters. So this much amount of fluorine is there. Okay. Then if the fluorine content is more than the permissible limit which is given by different organizations, then you have to think about the next technique, what we can do to remove excess of fluorine. Okay, so in this section we will talk about what experiment we are using and how we can remove this excess of fluorine. Okay, now you can observe here Colgate cavity protection toothpaste. It is fluoride filled toothpaste. So from the picture only we can understand we need fluorine for our body. What is the purpose of fluorine in our body? It will protect our enamel, tooth enamel, it will protect. But I already explained to you, it should be within the permissible limit. Okay? If it will be beyond the permissible limit, we are drinking that water for a long time run, it will lead to some problem. What is the problem? These are the problem, that is fluorosis. Okay? So different types of fluorosis is there. This is dental fluorosis, and next one is skeletal fluorosis. So compared to dental fluorosis, skeletal fluorosis is more dangerous. You can observe here, this is mild one, and this is moderate one, and this is heavy one. Okay, so this is dental fluorosis and this one is skeletal fluorosis. So what is the main significance of our experiment is we can understand how much fluorine is present in your drinking water. So you are analyzing your borewell water, just imagine. So in that borewell water, how much fluorine is present. Okay, as per WHO, I already told you there are some organizations like WHO, ISO, ISI, etc. As per WHO, in the drinking water, 0.5 to 1 ppm or 0.5 to 1 milligram per liter of fluorine should be there. Because we need fluorine. Okay, so that much should be there. But beyond 1 milligram per liter fluorine is we are consuming for long time run, it will lead to fluorosis. Okay, now we will discuss about the experimental part. So in the board I will explain all this procedure. So for this, for the apparatus purpose, what you need first is a potentiometer. What is that? Potentiometer. Okay. So first one is potentiometer. What is the use of this potentiometer? It is using to find out EMF of the between the two electrodes. What is EMF? Electromotive force. In other words, we can say it is a potential difference between two electrodes. So from the definition you can understand two electrodes, potential difference between two electrodes. So there should be two electrodes. One is, this one is reference electrode. What is that? A reference electrode. And the next one is attached to the potentiometer. This is ISE. I will explain now clearly. First one is reference electrode. Now, what do you mean by reference electrode? It means it will give a potential stability, stable potential it will give. Means just imagine one beaker I am taking 1 molar fluorine solution. Next in another beaker I am taking 2 molar fluorine solution. And this reference electrode only I am keeping here. For 1 molar I kept here. The same reference electrode I kept in 2 molar. In both the things, it will give a same potential. Depending on the concentration, depending on the conditions, it won't change the potential. And this is known as reference electrode. Okay? So, reference electrode we understood. It will maintain the stable potential. Now next one is ion selective electrode. What is ion selective electrode? The same example I am telling here. One beaker, I took 1 molar of fluorine solution. Another beaker I took 2 molar of fluorine solution. And here I am keeping this ion selective electrode, and here you will get an EMF of E1. Okay? So in this first beaker, that is 1 molar fluorine solution beaker, you are getting the EMF E1. The same ion selective electrode you are keeping in the next beaker, that is a 2 molar solution. So here you are getting the EMF E2. So from here you can understand, based on the concentration, potential also changes. Okay. So what is the meaning of ion selective electrode? It is particular sensitive to particular concentration of ions. if any electrode is sensitive to the concentration of fluoride ion, we can say it is a fluoride ion selective electrode. Okay, so these are the apparatus using for our experiment. First one is a potentiometer. Here you can observe the EMFs, maybe 200 millivolt, like that you can observe the EMF. And it is connected to two electrodes. One is reference electrode and the second one is ion selective electrode. So reference electrode, I already discussed to you. It will maintain a stable electrode potential. And what is ion selective electrode? Ion selective electrode means it will change the potential depending on the concentration of the ions. If it is a fluoride ion selective electrode, it will change the potential depending on the fluoride concentration. Now, what are the solutions using for this experiment? So, which solutions we are using for this experiments? First one is standard solutions. Okay, so we have to prepare different standard solutions. So what standard solutions we have to prepare? 1 molar, 1.5 molar, 2 molar, like that. So first you tell me what is standard solution? Any solutions we know the strength. Listen, I am taking 1 gram of fluorine and I am dissolving in 1 liter of water. So I know the strength. In that 1 liter, how much fluorine is there? 1 gram. So that is known as standard solution. Okay. So like that we have to prepare 1, 1.5, 2, minimum 3 or 4 standard solutions you have to prepare. Why? Because we have to draw a graph. So minimum 3 or 4 points should be there. Okay. And in order to prepare this, we are taking which compound we are taking? Sodium fluoride. NaF we are using to prepare different standard solutions of fluorine. And the next one is unknown. What is unknown? Unknown means your boiled water. You are analyzing your boiled water only. So unknown we are taking and different standard solutions we are taking. And each one molar we prepared in one beaker, 1.5 molar we prepared in another beaker, 2 molar we prepared, and one unknown solution we took in another beaker. Okay. So how many beakers are there with us? One is 1 molar solution, next one is 1.5 molar, next one is 2 molar, next one is unknown solution, that is your boiled water. Now, what you have to do? What you have to do now? Each one beaker you have to keep it here. First I am taking 1 molar beaker. So this 1 molar beaker you are keeping here. Okay. So here you are keeping, so already 1 molar solution is there. So this is 1 molar solution. So here how many electrodes are there? One is reference electrode and second one is ion selective electrode. So these both electrodes we dip in 1 molar solution. Then you will get an EMF here. Just imagine this is E1. Okay. So for 1 molar you got E1. Next, this beaker you change it to 1.5. Now you are keeping 1.5 molar beaker solution. Then you will get another EMF, that is E2. Why it is changing? I already explained to you. Here one of the electrode is ion selective electrode. So this ion selective electrode will give the different potential based on the concentration of the fluoride ion. Okay. Now you are keeping 2 molar, that is E3. Okay. Now last we are having what we are having? Unknown. Unknown solution also we are keeping the beaker. Then you will get the E4. Just imagine you are getting E4. So now you can observe here, for 1 molar EMF is E1, for 1.5 molar it is E2, next to 2 molar it is E3, for unknown you got E4. There is no compulsion that you have to take 1, 1.5, 2 etc. Why? Because some areas having high fluorine content. So then you have to prepare the standards like 1, 1.5 molar etc. But some areas have very low fluorine content. So at that time you can go for 0.1, 0.12, like that you can also go. So there is no compulsion that 1, 1.5 like that only you have to take. Okay. Now, we got 3 standards and 1 unknown. For each one you got EMF. Now what is our next step? You have to draw a graph. Okay. I already told you why we prepare standard solutions in order to draw a calibration graph. So on the x-axis you have to take log of concentration of fluorine and y-axis you have to take EMF. Okay. So x-axis you have to take log of concentration of fluorine and y-axis you have to take EMF. Now you got different values for this. For particular concentration, here one EMF. For this particular concentration, here one EMF. For this particular concentration, here one EMF. Three standards were there. 1 molar, 1.5 molar and 2 molar. So for all three you got one EMF and you are plotting all these 3 points as a straight line. Okay. Now I will tell you why we took log of concentration. Okay. So previously what we observed, here only concentration we mentioned. For 1 molar it is E1, 1.5 molar it is E2, next to 2 molar it is E3. So for each concentration we got the EMF. But instead of this molar, what we did? We took log of the concentration. Why? Because we have to take we have to get the straight line. Otherwise we will get the exponential graph. In order to convert into the straight line, we are doing this concentration, log of the concentration. So x-axis log of concentration of fluorine, y-axis EMF, then you will get a straight line. Now, simple mathematics I am telling you, y is equal to mx plus c. Okay, straight line equation is y is equal to mx plus c. So you can understand here what we took on the y-axis, that is EMF. EMF is equal to x-axis what we took, log of fluorine. So log of fluorine concentration, what is m? M is the slope. So I am writing s dot slope plus c. What is c? It's an intercept, that is a constant. Okay, so from the straight line equation we finalized what is the EMF equation. EMF is equal to S into log of concentration of fluorine plus constant. Okay, from here you can understand now we already plotted the graph with the 3 standard solution. 1, 2, 3. 3 points we already marked it. So what about the unknown solution? We already saw here unknown solution, we don't know the concentration. But we got the EMF. Okay, unknown solution concentration we don't know, but we got the EMF. So here you can observe EMF is equal to S into log of concentration of F minus plus constant. Okay, so here you can understand what is the log of concentration. How? I already told you for the unknown concentration you got the E4. The EMF value is E4. Now you already know the EMF of unknown. And from the calibration graph, you can get the intercept. Next step, you can get the slope also. So only the unknown part of your equation is log of F minus. But practically no need to do all this calculation etc. manually. The software or the computer or the whatever software you are using, that only will give all the values directly. Okay. Now I will go to this PowerPoint portion. So remaining things I will explain there. So you can observe clearly here. See, in this video you can observe here. This is the reference electron. Okay. Next one is the sensing electrode. That is ion sensing electrode. So through here the current will pass. And this is a beaker which contains the different types of fluoride solution. It may be standard solution or it may be unknown solution. Next here. We prepared 1 molar, 2 molar, 1.5 molar like the standard solutions we prepared and also unknown. In that you have to add some TISAB also. So TISAB means what is TISAB? Total ionic strength adjusting buffer. Why we are adding TISAB? In order to maintain the pH in 5 to 5.5. Why we are maintaining some other ions? See, in the water not only fluorine, some other ions will be there now. So like OH, etc. So that ions can interfere this experiment or these values can interfere. In order to avoid that one, we are using TISAB also. Next, already explained what is fluoride ion selective electrode. Next one is, this is a preparation solution. So this is the sodium fluoride. From that you can prepare 1 molar, 1.5 molar, 2 molar, etc. This is the diagram. So this is the diagram. Same thing I explained in the notes. So this is reference electron and this is reference electron and this is ion selective electron. This is a beaker and you are getting a potential here. Now this is the graph, log of concentration x-axis and this is potential or EMF. You will get a straight line and from this equation E is equal to constant plus S into log of concentration of F minus, you will get the unknown concentration. Now we will come to the principal part. Why you are getting different values? Okay. So two electrodes are there. this ion selective electrode, I am concentrating now. So this part I am concentrating now. So here, that only one part I took. What are the components of ion selective electrode we will see. See here, this part, this is the membrane. What is the membrane? It's a solid state membrane. Solid state membrane. It is made up of lanthanum fluoride, LaF3. Okay, so this is a membrane. Next, inside you can observe some solution. So this is a electrolyte containing very low concentration, that is 0.001 molar sodium fluoride. Very low concentration of sodium fluoride. Next one, electrode is there. Okay, so these are the components of the ion selective electrode. Now, you can observe here, I already told you this is a solid state membrane which is made up of LaF3. So this LaF3 is doped with europium. Okay, why it is doped? We already know what is the purpose of doping. So what is the purpose of doping? So in order to increase the conductance. Okay, because of the conductance purpose only, we increase the conductance by doping with the europium. That's why here already told you here one fluoride ions are there. Now this is only we are keeping in a beaker. Outside also fluoride ion is there. Inside also fluoride ion is there. So inside concentration is very low. So I can say now only 2 fluoride ion is there. Just imagine. Next, outside beaker I kept 1 molar, 1.5 molar, 2 molar, etc. So fluoride ion will be more. So here 1, 2, 3, 4, 5. 5 molars are there. So 5 fluorine is there. Okay. So what is happening? Because of this conductance, some voids will form. So this fluorine will insert or it will bound to the surface. And outside fluorine will bound to this surface. So here only 2 fluorine bounded and here nearly 5 fluorine bounded. Because of this activity difference, you are getting a potential difference here, and this potential difference only you are measuring with respect to the reference electrode. So this is the principle behind this, the same thing only. Next step. So now you understood how we are finding the fluorine. Okay. Now what I am going to tell. After this, you gave one sample to the chemical laboratory. They gave fluorine is this much in your water. Just imagine it is more than 1 milligram per liter. As per WHO, how much should be there? 1 milligram per liter. If it is more than 1 milligram per liter, what we have to do? You have to do something now in order to remove that fluorine. What is that method? And that method, one simple method is that is Nalgonda technique. Okay. So this is a Nalgonda technique. So this Nalgonda technique is developed by National Environmental Engineering Institute, that is NEERI. So what is the technique I will inform? See, this is a diagram. So what is a simple technique? Here, whatever water you have to treat, you take. In that you are adding 2 chemicals. That is, one is alum, next one is lime. What is alum? Al2SO4 thrice. That means aluminium sulfate form you are adding. So this aluminium sulfate, whenever you are adding to water, what will form? Aluminium hydroxide, AlOH thrice. Also, already one fluorine is there. Okay. So this fluorine can form AlF3. That is aluminium fluoride will form, and it is a precipitate. That is the equation. It is a precipitate. Also, we are adding lime. Whenever adding lime, why? What is the purpose of adding lime? In order to adjust the pH, and calcium hydroxide will form. So whatever precipitates formed, it is a step, this flocculation. What is the meaning of flocculation? Precipitation. So in this step, already precipitates formed. Now you have to remove the precipitate from the water. The soluble fluorine be converted into the insoluble form. How you can? This is a sedimentation process. What is sedimentation? Simply you keep that bucket, whatever vessel you are using, you just keep it there. Then whatever precipitate form now, it will settle down here. The clear water you are taking here, see, some small suspended particles will be there after sedimentation also. That you can remove by the filtration method. Okay. Now after filtration, you can take the tank, or you can save that water in the tank. So this is a flow chart. So mixing of chemicals, next to flocculation, next to sedimentation, next to filtration, and next to you will get a defluoridized water. So the same, this I already informed you, this is a simple technique. So same technique you can use in home also. So what you can do, simply you take the water in a bucket, you add this lime and alum. Already this needy developed some chips or kits. Okay, so that case directly you can add the particular amount of water, then mix it, the precipitate will form, you can just filter it. Sedimentation and filtration. Okay, so thank you. And before going to the details, so I want to tell you something. One video I want to show you. Okay, so here, see, this is the fluorine content. Determination of fluorine by ion selective electrode. So this is simple experiment. So here you can observe directly we are getting the fluorine amount, that is 14.7 milligram per microgram per liter. What is the meaning of that? It is very low, that is 0.014 only. So as per WHO, how much should be there? It is 0.5 to 1 milligram per liter. So it is very low also problem now, because we are not getting sufficient fluorine from the water. So next one more video is there. See, here I explained the Nalgonda techniques. So the same Nalgonda techniques. See here, precipitate formed. What we added? Two chemicals. One is alum. Next one is calcium hydroxide. So this aluminum hydroxide will form, aluminum fluoride will form. These all are precipitate. It is settling down during the sedimentation process. Next year it will settle down, and this water precipitate settle down now. We are removing now. Okay. So now it will remove. See, now after removing also you can observe some suspended small particles are there. So these small particles you have to remove. What we have to do? The next step is filtration. So in the case of filtration, what we can do? Some layers of sands. So here this is anthracite coal, next one is sand. So different layers of filter methods we are using, and the water is passing through here. Here you can observe. So these blue particles are the suspended small impurities. So that impurities, what will happen? It will stick to the sand and this anthracite. Okay. Now the clean water, it will go to the pipe and we can store in the storage. See, next one is disinfection. See, disinfection I didn't tell. Why? Because it's not a part of this experiment. Okay. But if you want more safe water, we can go for the disinfection methods like chlorination or bleaching powder, etc. Also you can go. Okay. So this method also it will be there. So after disinfection, it will go. See, disinfection means a chlorine. We are adding, it will kill the bacteria. If any microorganisms are there, it will kill the bacteria. Next, it will remain the treated water we are storing. See, this is the bacteria. The clean water we will store in the water tank, or we can use for the household purpose. So, just we'll revise now what we completed. We were talking about the fluorine content present in water. How to determine? What method we are using? Ion selective electrode method. How many electrodes are there? 2 electrodes. One is reference electrode, next one is ion selective electrode. And how many standard solutions we prepared? One is 1 molar, next one is 1.5 molar, and next one is 2 molar. Okay? And one unknown. Unknown, what is your unknown? Borewell water. Your borewell water you have to prepare. And each solutions you are keeping, and for each solution you will get the EMF. Okay? And after getting the EMF, what you are doing? You are plotting a graph. What is on x-axis? Log of concentration of fluorine. Y-axis EMF. Then you will get a straight line. What is the equation for straight line? Y is equal to mx plus c. From there, what equations you will get for the EMF? EMF is equal to S into log of concentration of F minus plus constant. So constant means intercept, M means slope. Okay. So if you know EMF, if you know slope, if you know intercept, we can find out the concentration of unknown solution. Next, what we told the principle. Which solid state membrane we are using? Lanthanum fluoride. Lanthanum fluoride doped with the europium. So because of the difference in concentration of the internal electrolyte and outside solution, they will bound. The fluorine will bound to the surface. Okay. So inside bounding and outside bounding will be different. Because of this difference only what you are getting, you will get the potential difference. You will get the potential difference from the, and that potential difference you are measuring with the respect to the reference electron. Okay. So this is a theory of the principle behind this one. Next, last what we told, we can, if we are taking high amount of fluorine, how you can remove the fluorine? What we can remove? What is the technique? That is Nalgonda technique. What we are adding Nalgonda technique? One is alum and next one is calcium oxide or calcium hydroxide. Alum why we are adding in terms of, in means of aluminum sulfate we are adding. That aluminum sulfate will precipitate, it will form aluminum hydroxide, it will combine with the fluorine, it will go aluminum fluoride. What is aluminum fluoride? Is a precipitate, it will settle down. That step is known as sedimentation. After sedimentation, what we will do? If any suspended particles are there, we can remove that particles. That is filtration, by means of filtration. So after filtration, what will be there? So after filtration, we can use for some disinfection methods also we can use if it required. So it's not part of this one, but it can use like chlorination, bleaching powder, etc. we can use. So after bleaching powder, that means the disinfection methods, whatever water is there, the purified water, that purified water we can use for the household techniques. Okay, so this is about the determination of fluorine content present in water by ion selective electrode method. And thank you everyone for this lecture. Thank you everyone for this. Thank you.